Okay, so for today, the only difference between today and yesterday is one little thing. Watch. Here it would have been yesterday. 2x plus 1 is equal to 5. And here's the difference. Hold on. And it makes the answer totally different. Right there. Greater than or equal to 5. That's it. Now, how can that make the answer different? Well, it's just like when you have absolute value. No, let's not even do absolute value. Just say a is equal to 5. You know what that means. If I say a is greater than or equal to 5, that changes the answer totally, right? 5 still works, but so do a whole bunch of other numbers. So when we have these today, we still solve them the same exact way, but then we figure out what the two answers are, and then we have to keep going and figure out what all the other answers are that will work. Okay, so let's just do this one together. Everybody, write this one down if you haven't already. And by the way, take this moment to say, you need a pencil. Even if you're a tough guy, you still got to do math. All right, so I am noticing that I have about 7 seniors in here. I have bad news for you. They officially said you're not getting iPads. They had just too many. There was like 46 seniors who were going to have to get an iPad. It was on the edge. They were torn about it, but they could give them to like 3 other curricular areas and like make those classes all work perfectly and then leave us without them. So that's what they did. And I know it was a tough call, but that was their final decision. So they did say there's still a chance that they might do something creative, but that wouldn't mean that they would give all the seniors iPads. It might mean that they have a few of them in the classroom for classroom use, but that kind of takes away some of the cool stuff you can do with them. But if they had enough, if they had 7 iPads in here for classroom use, that would be cool, because then I could give them out to the seniors and I could do some cool things like with flashcards or with instant response kind of stuff. I use the iPads really well in my other class, but anyway, good news is next year all seniors will have iPads. I know that makes the seniors right now feel like, yay, great. All right, anyway, I'm sure it makes you feel even better that they decided to give all the 8th graders iPads. Painful, but that's what they decided. So, I don't know. I guess they just had to make a tough call, and that's the way they went. Okay, now I'm going to solve this one without any iPad use. I'm just going to break it up right away into 2x plus 1 equaling 5 or 2x plus 1 equaling negative 5. Everybody do that with me on your paper or iPad. And now, I'm making sure that everybody's with me. I'm going to take off 1 off each of these, minus 1, and I will have 2x equals 4 and then x equals 2. Cool. Then I'm going to have 2x equals negative 6, x equals negative 3. And then that would normally be done, and a lot of kids forget to do the rest of the problem. That's what we would have done yesterday if it had just been an equals problem. But this is called an inequality, meaning it's not equal, it's greater than or less than. So what do? It's really kind of cool. You go back in time to elementary school, and you say, these are my answers on a number line, negative 3 and 2, and this is one of my answers, and that's the other answer. And then you ask yourself, where are the numbers that will work in this equation? Well, these are 2 of them. And if I actually put in negative 3 in here, does it work? 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. What's the absolute value of negative 5? 5 is 5. Greater than or equal to 5. Yes, it is. Remember, it doesn't have to be greater than and equal to. That's impossible. It's either greater or it's equal or it's not. And this one is 5. And is 5 greater than or equal to 5? Yes, it is. So it works. So I'm going to fill it in. Do you remember that about those? That if it works, you fill it in? Okay, now I'll go to the other one, the 2. Does the 2 make it work or not? I'm going to put a 2 in. 2 times 2 is 4. 4 plus 1 is 5. Absolute value of 5 is 5. Is 5 bigger than or equal to 5? Yes, it is. So it fills in. 2 worked. And I stuck the number 2 in. What? That's our answer so far. But remember how I said before that, like, if I said a is greater than 5, that 5 is, or equal to 5, that 5 is one of my answers, but there's a whole bunch of other answers that also work. There's a whole bunch of other answers that also work in my absolute value. And I just got to figure out if those answers live in region 1 or region 2 or region 3. So we check them. And so we say, like, what's a nice number that's between -3 and 2? Any nice number you want. 0. 0 is the best number to test because then it makes things cancel. So if I put a 0 right here, get how 2 times 0 makes 0? 0 plus 1 is 1. That's really quick to figure out. So is 1 greater than 5? No, so it did not work. I tested here and it did not work. You put a big X across it. Now I'm going to test another spot. What's something bigger than 2 that might be over here? 5. Sure, let's test 5. I stick a 5 in here. Is 2 times 5 is 10. 10 plus 1 is 11. Is 11 bigger than 5? Yep, worked. So it works here and we fill it in. And it'll work forever that direction then. The cool thing is that means everything in that little zone works. And also, usually, if the one in the middle doesn't work, the 2 outside ones work. I would bet that it's going to work over here. But I would always check. It keeps you from making mistakes, double checking. You really want to be careful with these because sometimes it doesn't do what you expect. All right, if I test -4, I'm going to stick a -4 in here and see what happens. 2 times -4 makes -8. -8 plus 1 makes -7. What's the absolute value of -7? 7 is 7, greater than 5. Yep, it worked. Okay, so then it worked here after all, I thought it would. It's good to have an idea of what you expect to happen, and then if it doesn't happen, you can like double check and make sure like it should be working and it's not. Sometimes you're right. All right, and then we're still not done. This is what makes it precalc. There's so many steps. First I had to split it, and I had to solve it. Then I had to draw my number line and check some regions, and now I still have one more thing, because the directions are going to say, write your answer as an interval. So then, you just have to like say from 2 to infinity works. Know what I'm talking about? You remember those? And then what's the other interval? It's from -infinity to -3. Also works, and you never have a bracket around infinity because that would imply you could get to infinity, and you can't. But it will work. The number at -3 will work, so I have to put a bracket around it. And then how do I put these together? A U for union. There's your final answer. Long, but not hard. I keep on telling you this about precalc. It's really true. Each step isn't that bad. I mean, come on, splitting it up into equations. One's positive, one's negative. That's not that hard. Solving a little baby equation. You did that in, seriously, most of your 7th grade you were doing those. And then, from there, you take your answers and stick them on a number line. You were doing that in 4th grade. Yes, it is. I know you may question that can't you just jump from this to this? Nope, you really can't because you don't know what your numbers are going to be. You don't know where it's going to work, and just trust me, we're going to do tons of stuff with number lines, and you're going to get used to it, and once you get used to that process, it'll make it easier so that every time we have to do number line stuff, you'll know how to do it. The only thing you could do different on this number line is if you're more comfortable making it a bracket like this instead of a filled-in circle, that'd be okay. You could use a bracket on your number line. And if it doesn't work at that spot, that would be if this says it doesn't have an or equals, if it's just a greater than, then it won't work on the endpoint, and you'd leave these empty as empty circles, or you would have a curve, like a parenthesis. But we're going to do one like that right now. Okay, here we go. Absolute value of 3x plus 1 is less than 6. Everybody try to do this one yourself completely. Just be careful with the endpoints. Come around and check it. If you aren't dividing it up right off the bat, you're already screwing up. Don't try subtracting 1 until after you've made your 2 separate equations. I'm going to pause while I walk around and check you. Okay, so your first step would be 3x plus 1 is equal to 6, and 3x plus 1 is equal to -6. That's because what's underneath here is either I want to check 6 and I want to check -6. And again, it doesn't say equals this time. That's going to be a little different. But I still want to set it equal on my little equation. I'm just finding important points on the number line. So then I subtract 1 from both sides. 3x equals 5, x equals 5/3. And you might know, I don't know where to put 5/3 in the number line. All that matters is that you put 5/3 on the number line in generally the right spot. Subtract 1, and I got 3x equals -7, x equals -7/3. And then if I put it on a number line, oops, wrong way. Number lines go this way. I have the -1 down here and the +1 here. Don't worry about exactly where is it. All you need to know is keep the positives and negatives right. And now remember, these numbers actually don't work this time, because if you actually plugged in 5/3 into this equation, let me show you what happens. If I put in 5/3 right here, I get the 3's cancel, 5 plus 1 is 6. 6 is less than 6. It's not true. It doesn't work. But it is the end point on the number line. It's an important point still, but it doesn't work there. So I leave this as an empty circle, or if you'd rather, you can use a parenthesis. But the only problem is you don't know which way to draw the parenthesis yet, because you don't know if it works in here or if it works out there. All right, so I like the empty circle thing better than the parentheses. All right, so now we got to test the zones. The easiest number of all to test is 0. 0 falls in here somewhere, so I'm testing 0. I stick a 0 in right here. 0 goes in there. 3 times 0 is 0. 0 plus 1 is 1. 1 absolute value is 1. Is 1 less than 6? Yes, it worked. Works in here. I bet you anything if you test it outside, it didn't work. Am I correct? All right, so you test out here. You stick in a number bigger than 5/3. If you're not sure, like, well, 5/3 is some kind of fraction, pick a big number like 10. Check 10. Any number that's over there. So I could pick a 10. 3 times 10 is 30, plus 1 is 31. Is 31 less than 6? No. So it doesn't work out here, and it doesn't work out here. Final answer is between those two, which the only difference was they're empty spots on the ends here. So they're parentheses. -7/3 to 5/3. That's a typical, to be honest, it's probably an R2 level question. It didn't have any word problem associated with it. You didn't need a calculator to do it. That'd probably be one of your easy ones. If we stepped it up with a bunch more algebra in it, then it might be an R2 or R3. But this is probably like one of your easy ones. You can survive this class by just getting R2s right. The thing is, your best you're going to get is a C for a grade. And I know most of you would rather have B's or A's, and so therefore you're going to need to get some of the hard ones right. An example of a hard one might be, actually, they're not even that hard. Those problems where they give you a data table and you type in all the data, and then what's that thing called? Something regression. Linear regression. That would be an example of a hard problem. Believe it or not, I think a lot of you would rather do that than this, but anyway, because you're good at technology, you can probably whip that calculator one out pretty easy, and there's one of your A-B kind of questions. Okay. Only other thing I got to show you is how this could have been solved with a calculator. So I'm going to go back in time, undoing all my writing here, and I'm going to say, if I had had a calculator, what would I have done to solve this problem? If I was going to solve this problem with a calculator, I would simply graph both sides and see where they cross. That would be kind of important, right? So let me just get a quick sketch of what it would look like. Do you remember that the absolute values are V-shaped things that generally start like this? And then do you get that 3 on the inside is kind of like maybe stretched it or shrinked it a little bit, and then the +1 moves it left or right? So generally it looks something like this, except the V might be a little squished. Okay? And then that 6, y equals 6, where would that line be? A line like this at y equals 6. Now, where those overlap is what's important. Look at where they touched. Take a guess. That point and that point. What do you think they are on the number line? Those are those two spots on the number line. Yeah, like the -7/3 and the positive whatever. All right, so if I were going to graph this thing, I would say this is the, what was it? What was the positive one? 5/3. This is 5/3, and the negative one was -7/3 over here. Okay, these are these two spots, there and there. Are these two important numbers? Did they work? No. And where did it work? In between. Now, how could you tell that? Think about it. Where is this less than the 6? Here's the 6. What do you think less than seems like? Under it or above it? Under it. It's like, where is the absolute value under the 6? And it's right in here, in this little zone. So it's right in here, in this little zone. See how you could have done it with a graphing calculator? All right, let's try one right now. Everybody grab your graphing calculator, put in this 2x minus 1 and greater than, let's go with 4. Don't do it algebraically. Just type it into your calculator, graph it, see what happens. And then hopefully you can look back at this and try to figure out where the absolute value, the v, is bigger than the 4. I'm going to pause for a second while I graph this. Yeah. Okay, I got my calculator going here. 2x minus 1 going in the absolute values. And then underneath that is the second line, which is the 4. And I just type in a 4. And I hit enter. And then I graph them. And then I just am smart about how I read this thing. The absolute value and the line. What I want is, where is the absolute value bigger than or greater than, or what do you think that is, above or below? Above. Where is my absolute value above the 4? Well, I can look at this and say that the v thing is above the other line from here to here and from here to here. Do you get how that's kind of like a number line where you've got 2 spots and it works here and it works here? Get what I'm doing there? And how could you figure out those 2 spots? By doing second calculate, intersect. You could see where they intersect, and that would tell you those spots. Does that make sense? All right. Now, I personally don't like this way of doing it because I think it takes too much time. But if the equation was really ugly, do you get where I'm going here? If I had to solve a really nasty equation, I could just type it in and do second calculate intersect. But if they're nice simple numbers, I'd probably rather do it by hand. So it all depends which one you'd rather do. Okay, personally, on an easy one, it's easier to just do it algebraically. But if the numbers are nasty, I'd grab my calculator. This test's coming on Wednesday of next week. There's no calcs. So you have to know how to do it by hand. We won't give you any numbers that are really nasty either. But just understand that you can't just say, well, I prefer to solve them with graphing, Mr. Server. That's nice, but the test on Wednesday is not a graphing test. That'll be the next one. So the first test you have, no calcs, then solve algebraically. Next test you have, solve with graphing. All right? So I got to teach you the graphing stuff. I can't just like skip it, because we are going to get tested on graphing, but it isn't going to be for a while. All right, I think the best thing to do now would be to actually get the first couple of problems of your homework done, because I think you're more likely to get her all done if you get some done with me. We are going to skip some of these problems as well. We are going to also enter some homework, because I have a bunch of blank spots in the gradebook right now, and I'm going to ask you for those scores in a minute. I'm going to continue to record right this second because I want to show the people at home how to do the first couple homework problems. Yes, sir.
How do I use calculators on this?
Your homework has got 2 sides. The front side, solve by graphing. The back side, solve algebraically. So you're going to be trusted to use your calculator at the right times. Okay, number 1. Let's do it together. Super simple on the calculator. And all I need is a sketch of it, and then you can go right to the answer. So let's get that thing on the calculator, which is absolute value x plus 4, and then greater than or equal to 5. Now, since it says greater than or equal to, I know that the end points, those points that are on the number line, they're going to work. Now, I just got to figure out whether I shade between them or I shade on the other sides of them. All right. So again, this one's a graph one. Front sides is graphically. So you can't just, I know, but solving it by hand would be really easy, but don't. Okay, so x plus 4, and then this other one is 5, and then I hit graph, and now I ask myself, where is the absolute value, the v thing? Where is that bigger than the 5 line? Well, where is it bigger? It's bigger there and there. So if I knew these points on my number line, I'd shade here and here. And how can I find those points on the number line? Second, calculate intersect. Go ahead and do that. And somebody tell me what's the positive one, the small, is it exactly 1? Awesome. This one's 1. What's the negative one? -9. Do they work at that spot? Yes, because it said or equal to. If it says or equal to here, then it will work on the endpoints. Okay, so final answer. If I was going to write it in a brackets and parentheses kind of deal, I would say from 1 to infinity it works with a bracket because it worked at the end. And the other side is negative infinity to -9, bracket, parentheses. And what's squeezed in between them? U for union. All right, and to be honest, I feel like we've given you more practice on this than you need, and so you may skip problems 2, 3, and 4, just to save you time. You know what? You can also skip number 8. Just do the other ones well. I don't think you need that much practice. Now, if you realize you need more practice, just do one of the ones I told you to skip. That won't hurt. You're skipping 2, 3, 4, and 8. Okay, flip it to the other side. Let's do one of the algebraic kind together. All right, on the other side, let's do, well, number 9's too easy. Let's do number, let's go to number 13 together. Everybody, let's do number 13. And it says absolute value of 4 minus 3x, absolute value minus 2, is less than 4. And now the first thing I should do is not graph it, because this is not the graphing side. I got to get that absolute value alone before I can split it. So, plus 2. Add 2 to both sides. 4 plus 2 makes 6. I'm just going to cheat and do that. It's a lot faster. What I did there, I just added 2 to both sides. And now, I'm going to split it into 4 minus 3x and 4 minus 3x. And one of them says equals 6, and what does the other say? Equals -6. Good. And then I'm going to solve both equations, and I'll get my 2 key points. Once I got my 2 key points, I'm going to graph them. And then I'm going to test regions around them. And yes, it's a pain in the butt. That's why this worksheet's a little bit long. So on this side of the worksheet, why don't you skip 11, 12, and I think I'm going to do 15 for you so we don't have to skip that. I want to show you how to do one of those. So just skip 11 and 12. All right, so back to this. I'm subtracting 4, and -3x equals 2, and x equals 2/3 with a negative. There we go. There's one of my important points. The other one. I screwed something up here. It's just a 4, not a 4x. Okay, and now I'm going to subtract 4. I get -3x is equal to -4 with -6 makes -10. And then I'm going to divide by -3. X equals -10 divided by -3 makes +10/3. It's also known as about 3 1/3. And then if I were to graph them, the important spots are, doesn't even really matter where these are, just that the positive one's on the right and the negative one's on the left. And I circle them in their important spots. Do they actually work? Check the sign. If it says or equal to, it works. Does this say or equal to? No, it does not. So they do not work. Empty circles, parentheses later. And now I test the zones. What's the ultimate number to test? 0. 0 falls in here. I test 0 by sticking in a 0. Put in a 0 right here, and I get 3 times 0 is 0, 4 minus 0 is 4. Absolute value of 4 is 4. Is 4 less than 6? Yes, it is. So it worked in that little zone. So if it works in here, 90% chance, not 100%, 90% chance it's not going to work on the outsides. I'm just going to check one of them. I'm going to check a big number like 10. Stick in 10. See if it works. 3 times 10 is 30. 4 minus 30 is -26. Absolute value is 26. Is 26 less than 6? No, didn't work. Told you. Canceling both of those. And now, final answer is between those two. You write it with the brackets and parentheses deal. -2/3 to 10/3. Any questions about that one? All right, let's skip on to number 15. I at least want to start number 15 with you because I think I can give you a good tip. A lot of people see this one and they want to clear that fraction right away. And I love that you want to clear the fraction because you're right. You want to multiply by 3. But don't start with that. What you should start with is it's an absolute value. You've got to do what before you can start solving it? Split it. X plus 2 over 3 greater than, oh, no, just say equals 3. Equals 3, and x plus 2 over 3 equals negative 3. Now you can clear the fraction by multiplying by 3. So times by 3 here, times by 3 here, and then those will cancel. I get x plus 2 equals 9, and I subtract 2, x equals 9 minus 2 is 7. Over here, I'm going to, let's see, on times by 3 on both sides, and I will have cancels, x plus 2 equals negative 9, subtract 2, negative 11, and there we go. There's my two important numbers. Do I stop right there? Of course not. There's got to be more to it, or I wouldn't have said that. It's the number line. Negative 11, 7. Do these spots work? I checked that by checking this. Since that says or equal to, they're going to work. Filled in circles, filled in circles. Now I'm going to check my favorite number of all, 0. Check 0, stick in a 0. Anyway, I got carried away. I didn't mean to do that much of the problem for you. But it's mostly done. I just got to check your intervals. You know a sad fact? Questions like this are on the test. And kids get to this part and they so often test their intervals wrong. Like they get all the work done, they get the numbers right, they fill in the circles right, and then they test these wrong. Like they check. So I would, if I were you, honestly, I would check twice on a test. Now it's on a homework, it isn't that big of a deal if you get one wrong. But on the test, you only get 4 problems to try for your A or your B, you know, your R3 questions. You only have 4 questions. And that's a really common screw up is kids put in a number wrong and then they just trust it. Like, say you're putting in 10. And the kid puts in the 10 and checks it and screws it up. Make one little mistake in there and it'll tell you that it doesn't work when it really does. So double check your intervals on the test. Because so often, everything was perfect, they shaded the wrong area. So common. All right, 10 plus 2 is 12, 12 divided by 3 is 4, absolute value of 4 is 4. Bigger than or equal to 3? Yes, it works. But seriously, if it was a test, I would try one more number, like 12 or something. And try it again and make sure you didn't screw up a little thing. All right, if it works there, it's probably not going to work here, and it's probably going to work down here. Can anybody verify they checked that? All right, some people verify that. Okay, good. So then the final answer must be that there's a little thingy here, union with another thingy here, but you figure that out, it's brackets. And anyway. Okay, that's all I got for you for today for the video.